Hi everybody, welcome to section 3.4, which deals with geometry applications, and it's one of my personal favorite things because we get to talk about properties of triangle and then the Pythagorean theorem, which of course is super popular and amazing. Okay, so how to solve some applications or word problems that use geometry. So same kind of deal, we read it, we identify, we choose a variable to represent what we're looking for, we translate it into an equation, writing a formula or model the situation, we solve the equation, and then we check the answer. And if there's a picture to be drawn, we draw it. That also helps a lot. Okay, so first let's let's refresh ourselves with triangles. What's a triangle? A triangle has three sides and three vertices. This is a vertice here. A, capital B, capital C. And the lengths of the sides, usually the length of the side is opposite, has the same letter but lowercase of the angle. So this is angle A and this is side A. This is angle B, and then this would be side B, and then angle C, and then side C. Okay, so how are they related? There's a lot of ways that they're related, but one of very popular ways is that the measures of the three angles is equal to 180 degrees, okay? And so that's one thing about the triangle that we're going to use. And then also that the perimeter is just the sum of its sides, okay? So to find the area, we need to know the base and height. Okay, so now we have the same triangle, but now look, we have the height here, which is h. Okay, so it's the height is what connects the vertex to the opposite side in a 90-degree form. In other words, this is perpendicular, right? We call that perpendicular. Okay, and so it's the height, and the formula for the area of a triangle is 1/2 base times height. Okay. Let's see what else. Okay, yeah, so again, just to recap, the sum of the angles add up to 180. The perimeter is just the sum of the sides, and then the area is 1/2 base times height, and that's triangle properties. Okay, so we're going to be using those properties for some word problems. Okay, so now we have here the measures of two angles of a triangle are 55 and 82 degrees. Let's find the measure of the third angle. So we're going to use, that the measures of the three angles of a triangle is 180 degrees. So we're going to use that. So let's say the measure of the first angle is 55 degrees. The measure of the second angle, 82 degrees. And the measure of the third angle, we don't know. Oh, I meant to do question mark. Okay, so we could let that be X, or we can actually just use measure angle 3 like that. So what we would do is just plug this in, right? So you see what I mean? So 55 would go here, right? So we would, and then we would have 82 degrees would go here, okay? And then this one we could just leave alone, okay? So rewriting this, we have 55 plus 82 plus the measure of the third angle is equal to 180 degrees. So then adding like terms, we're going to combine these two to become 137 plus measure of angle 3 is equal to 180 degrees. Subtract the constant from both sides, and we get measure of angle 3 is equal to 180 minus 37, which is 43 degrees. Okay. All right, let's do another one here. We have the measure of two angles of a triangle are 31 and 128. So one angle is 31 degrees. The little tiny circle means degrees. The measure of the second angle is 128 degrees. And then the third angle is we don't know. So question mark. So again, same kind of situation. We add the first and the second together, and then we let the third one be represented by measure of angle 3. That M, angle 3. And that's going to be equal to 180. And we can add these two together. That becomes 159 plus measure of angle 3. This is degrees. Okay, we don't write it all the time. We could just leave it like that, but that's fine. And then we subtract 159 from both sides. Okay, and we get measure of angle 3 is equal to what? that's going to equal to 21 degrees. Okay, so that's how we do that. Okay, let's do one that has perimeter. So perimeter of a triangular garden. So again, so perimeter, remember perimeter is if you have 3 sides, the perimeter is the sum of all the sides. In fact, the word perimeter comes from, peri and meter, meaning the distance, meter being distance and peri meaning around. So if you put it together, it means the distance around, okay? So we know that the perimeter is 24 feet. The lengths of 2 sides are 4 feet and 9 feet. How long is the third side? So if we have a triangle has 3 sides, A, B, C, let's let one of them be 4 and the other one is 9. What's the third side? We don't know, so we'll let that be C. So plugging it in, everything into this equation here, we have P is equal to ABC. So 24, that's our perimeter, is equal to 4 plus 9 plus C. Okay, so we just plugged it in. Okay, so remember this is P equals A plus B plus C. And then A and B is arbitrary, you're still going to get the same thing no matter how you labeled it, however you called it. So this is 13 plus C. We subtract both sides by 13. We get 11 is equal to C. And so your third side, C is 13 feet because that's the units that we're using. Okay, so here again, we have the lengths of 2 sides of a triangular window are 7 feet and 5 feet. The perimeter is 18. So perimeter is 18 feet. 2 sides are 7 and 5. What's the third side? Okay, we don't know. So if you were to draw this triangle, you could if you wanted to. You have something kind of, here's 5, here's 7, here's question mark, okay? So 18 is equal to 7 plus 5 plus C. Okay, so 18 is equal to 12 plus C. Subtract 12 for both sides. We get C is equal to 6, right? So the third side is 6 feet because that's the units that the problem is giving us. Okay, then we have this problem. The area of a triangular church window is 90 square meters. So we have area. The area is 90 square meters, or meters squared, right? The base of the window is 15 meters. What is the height? So for this, we're going to need the formula. Area of a triangle is 1/2 base times height. So we're just plugging things in again. So we have area, 90, A. So we're going to plug that in for A. So that's 90. And then we have, I just like using colors, I guess. We have the base is given to us to be 15. So we're going to plug this into here for base, right? So that's going to be 15 here, right? And then we have H. We don't know what it is. So that's what we're going to let that be H. Okay, that's going to go, right? So let's go ahead and fill it all in. So 90 is the area. That's equals. This 1/2 is part of it, right? And then they're right next to each other. So that means multiplication. And height we don't know. So let's leave that as H, our variable, okay? So 90 is equal to 15 over 2H. So multiply both sides by the reciprocal of that. Okay, that will cancel this out and you get H. And then 15 goes into 90 how many times? It goes into 96 times, right? 15 divided by itself is 1. 90 divided by 15 is 6. And then you have that H is 12. So the height is 12 meters. Okay, so that's the height. Okay, let's do another one. A triangular tent door has area equal 15 square feet. The height is 5. What is the base? Okay, so 5 and then the base we don't know. So area is equal to 1/2 base times height. 15 is equal to 1/2. We don't know what the base is, so let's let that be B. And then the height is 5, okay? So what we really have here is 15 is equal to 5/2, right? Because this is 5 over 1, and I can commute these two times B. So multiply both sides by the reciprocal of B, and then that gives you, that cancels out on the right-hand side. We get B. 5 goes into 15 3 times. 2 times 3 is 6. So base is 6 feet. Okay. All right, let's talk about right triangle. So right triangle is defined as something that only has one right angle. Okay, that's a square here. One angle of a right angle measures 28. So if you have, So if you have one of these angles here, let's say this one is 28 degrees, and we don't know what the third one is, so we'll call it X. Because we know it's a right angle, we know that 90, it's going to be part of it. The other angle is 28, and then the third angle we don't know, and all that together is going to be 180. So we have 118 plus X is equal to 180. Subtract both sides by 118, and we get X is equal to, and then we have, what is that? That's going to be 62 degrees, okay? All right, so let's say here, now we have the measure of one angle of a right triangle is 20 degrees more than the measure of the smallest, okay? So we don't know what these are. So we have measure angle 1, measure angle 2, measure angle 3, okay? Well, one of them is going to be 90 degrees, right? Because we know that this is a right triangle. So one of them is 90, de hecho. But the other one, we don't know. We know that one of them is 20 degrees more than the other. So let's say this one, this one is 20 degrees more than whatever this one is. We don't know. So we'll let that be X. So if the smallest one is X, the next one is X plus 20. And of course we have 90. So together, all these three angles is going to equal 180 degrees, okay? So let's go ahead and do like terms. We have 2X plus 110 is equal to 180. Subtract both sides by 110. Okay, we get 2X is equal to 70. Divide by 2. We get X, which is the measure of the smallest angle, is equal to 35 degrees. So measure of angle 1 is equal to 35. The measure of angle 2 is going to be 20 more than that, which is 55. And then the measure of angle 3, we said it's 90. Okay, so that's it for this one. Okay, so now we have another one. The measure of one angle of a right triangle is 30 degrees more than the measure of the smallest. Find the measure of all three. So same deal here, same kind of situation. We have three angles. One of them is 90, okay? One of them is going to be 30 more than the other, but we don't know what that is, so that's going to be our X. And then we add them together to get 180 degrees. Okay, so then let's combine like terms. We get 2X plus 120 is equal to 180. We're going to subtract both sides by 120. We get 2X is equal to 60. Divide by 2. We get X is equal to 30 degrees. So measure of angle 1 is going to be 30. And then the next one, the bigger one, is going to be 30 plus 30, 60. And then the third one, of course, because it's a right triangle, is 90. Okay, so now we're going to talk about Pythagorean theorem. Okay, so Pythagorean theorem, first we need to understand that there's three parts of a right triangle. So this deals for right triangles only, okay? Triangles, all right. This should say triangles. So the right triangle, wherever the right angle is, it has these sides that are the leg. The side that's opposite of the right angle is called the hypotenuse, and that's the longest side. Okay, so any right triangle that exists in the world that you can think of has this special relationship with each other that if you square, let's say I let the legs, be called A and B and the hypotenuse C. If I square the legs and I add them together, so the sum of the squares of the legs is equal to, I'll get equal to the hypotenuse squared, okay? So it's really important. This is a pretty big theorem. It kind of revolutionized things, and you can imagine it kind of just changed the game, after that. Okay, so just to recap, in any right triangle, a squared plus b squared equals c squared, where a and b are the length of the legs of the triangle and of the right triangle, and c is the length of the hypotenuse. Okay, so let's go ahead and use the Pythagorean theorem to find the length of the hypotenuse below. Remember, a squared plus b squared is equal to c squared. Now, it's arbitrary what a and b is. It doesn't matter, but as long as you know that it's the legs. So 3 squared plus 4 squared is equal to c squared. That's the hypotenuse. So 9 plus 16 is equal to c squared. 25 is equal to c squared. How do we get rid of the squared here? We do what's called the square root. Okay, that's the inverse operation, right? So then c will equal 5. The square root of 25 is 5 today. Okay, so that's kind of how you solve problems using Pythagorean theorem. Let's do another one. So a squared plus b squared is equal to c squared. You have here your legs, and then this is the hypotenuse. 6 squared plus 8 squared is equal to c squared. We have 36 plus 64 is equal to c squared. 100 is equal to c squared. Take the square root of both sides. We have c is equal to 10. Okay. All right. So let's use this one more time. So this case, notice that the leg, we don't know the leg here. So I'll let this be A. It doesn't matter what I call it. And then this one will be B. So for this one, using the Pythagorean theorem, I would write a squared plus 5 squared is equal to 13 squared. Because we don't know what the leg is, right? So this is going to be 25. This is 169 here. Solving for A, right? We get a squared is equal to 144, and then take the square root of that. We get a is equal to 12, okay? So then here, the Pythagorean theorem would tell us 15 squared plus b squared is equal to 17 squared. Okay, so then we have, I'm sorry. Sorry, I started. Something's in my throat. Okay, so we square 15 and we square 17. Okay, so just give me a second. So we have here 15 squared, 225, plus b squared is equal to, and then 17 squared is 289. So solving for b, we're subtracting 225 to both sides. Okay, and then we get b squared is equal to 64, right? So take the square root of that, and what is that? That is 8, okay? All right, so we'll pause here and continue in the next video.